So I thought I'll talk a bit about the power modifications I made to my camera, just because I've been testing a few changes I made to it. So I'll show you what it is first. So normally you have essentially a dummy battery, DC coupler. I have another one here, which is the stock one. For some reason you get two when you buy them. That just goes in here and you have your little rubber flap, and you have a power cable that plugs into the little barrel jack in there. So I'll put this away now that you've seen it. And the top here plugs into a USB power bank. Now normally, so this is my cable. I have pretty much just bypassed the little DC to DC converter that was in the middle. And what I did was I put the converter actually in the battery pack itself, so there was no inline device. I also did a few other changes. I'll tell you about that in a minute. So I get this stuff off. So I'm going to do my finalized changes for this. Let me change the light angle for a second. There you go, it's a bit better. So the DC to DC converter just literally sat in this little thing, and it was, enclosed off. And then I got the idea of, I wonder if there's enough room to put that converter inside the battery. Cool, they're both pretty lightweight. I'm pretty sure this is the empty one. These things crack open pretty easily. These are like, if you get them off eBay, this sort of kit is going to be the standard one you get. So if you want to duplicate this, just pretty much get any kit you can find. They're all the same, I think. Just make sure it has a little thing that looks like that for the 5 volts to 8.2 volts converter. And these are all the same, I'm pretty sure. While I'm at it. Just disassemble this. Splatter solder everywhere while I'm at it. So I'll try to get this open. Try a different corner. There we go. I don't have much holding them together, just a little bit of glue, I believe. Tiny bit of glue, that is. hopefully that will be it. There we go. As you can see, there's literally not much to it. There's no active components in there, mainly just a little, I think they're capacitors. Just bridging the power channel to help eliminate a little bit of, I guess a little bit of decoupling. Now what originally got me thinking for my second modification was, there's like a little power socket here. I thought, oh, maybe these used to have a little capacitor bank or a battery inside, so you could actually use it as a battery while you change over your main power source. I thought, I should recreate that. But first things first is the little power supply that fit in this was literally a perfect fit height-wise to fit in here. And as you can see, the diameter would easily fit in there. Now this, I put a little bit of glue into it, but I need to crack it open because I want to put this diode inside it. And I hope I have room in there somewhere for it, because it's pretty jammed in here. Mine only has the tiniest bit of glue holding it together because I knew I was probably going to be cracking it open again later. So you can see mine is a bit more full. So there's the DC to DC converter. As you can see, I had to shorten this board a little bit, but luckily there's nothing important there. These little capacitors here, I relocated one to on the board there, I think, or was that the original? Oh no, I think, yeah, I put some, if you can barely see them, if it'll focus. It's hard to see, but there's just two of them jammed on the final output. But yeah, I hacked off that little lip of this PCB, that section, with the saw blade. Pretty easy to do. I thought, I might as well add a battery while I'm at it. And of course, this little battery here fitted in pretty much perfectly. I won't go into detail about how it's all wired up, but the basics is, and you should understand the basics if you do anything like this. So this little board takes 5 volts in and converts it to 8.2 volts out. So that's voltage. Your current is going to be higher on the 5 volts because 5 volts is your potential and the current is your the amount of electrons essentially. So the total power, the wattage, needs to be the same on both ends minus whatever loss this device eats up. So you're going to have your slightly lower current but higher voltage coming out this end. So in comes your same amount of power but higher voltage, and in comes your same amount of power but lower voltage but higher current, and out comes the same amount of power minus a tiny bit of loss at a higher voltage but lower current. The battery here is your standard lithium ion 4.2 maximum voltage battery. So that would charge directly off of 5 volts pretty easily, but that voltage difference, you don't want to overcharge these. So what I've done is I've put in a little, I've got one here. Not sure if this is the exact same one. No, it's slightly different. Essentially, these are just pulled off of old cell phone batteries. I've wired up the battery side positive to negative to the exact same one here. And two of these terminals will be the positive and negative output. It's up to you to figure out what's what, because each of these things is a little bit different. So this is what I'm sort of talking about. You usually have a little strip like this. Here's your main cell. Here's your battery protecting circuit. And that usually sits in there and it's soldered to the actual cell itself. And this thing will, now it's up to you to check. There's a little chip on it which tells you, which has a number. Like this one here might, looks pretty dirty. I'm not sure if it will focus on it. It'll sort of focus. Anyway. So you usually have a smaller device, which is usually a little MOSFET, which is the switch essentially that turns the battery, well, doesn't turn the battery on and off, but it isolates the outside supply, this terminal, from the battery itself, these terminals. Then you have your bigger chip here, which does essentially your sensing. It figures out whether your battery is under voltage or over voltage or being discharged or shorted too much, and it will detach the battery, turn it off, essentially the connection to it. So that's why I have this in line, so when this is overcharged or undercharged, it'll just disconnect the battery and save it. If you overcharge the lithium ion battery too much, it'll die. If you overcharge it too much, it'll get hot and explode, literally. So you need that little protecting circuit. And this one just fits in. So the battery output is connected just essentially parallel with the 5 volts in. So that'll work pretty good, except for when I connect this up to your standard battery phone charger. The phone charger would, I think it would sense the battery and it will try to charge the battery up, which is good and all. And the extra power is providing power for the camera. The charger doesn't know, it doesn't care. But I believe what happens is eventually, once the battery is full, it'll cut off. So the phone charger, I'm guessing, might sense that it's cut off and that voltage has disappeared, and it only senses a little bit of load from the rest of this electronics, so it turns off. And because this battery itself is detached from the circuitry by the isolator, or battery protection circuit, sorry, and then the power supply, like the main power supply, phone charging circuit, or wall power socket, whatever it is, it's providing 5 volts, also turned off. The power to the camera completely disappears and it turns off. So I thought, what if I tried a diode in line with that, so that the power can only go one way into the system, and that any sensing that the phone charger is doing to sense this little battery won't be able to work. So the phone charger has to simply work in a different mode of just providing power, which I believe is what they do. And I tried this and that worked fine. So now I'm going to try find somewhere to put this. That is, I might have to put it there. I have to put it somewhere. So that's going to be my first step. And then I'm going to take these leads and merge them with because these are pretty gnarly, I mean, look at them, and merge them with a good cable with a, nice 90-degree adapter. So I don't have to worry about cables jouting out massively. So I will pause here and get all this ready. Just dab of solder on here. And try to pull this power lead off without burning myself. There we go. I really need better light here. So now I believe that is the positive voltage, which is what I want to isolate, and not isolate, but block the direction of flow with this diode. This diode is like 3 amps, I believe. Oh no, 5 amps, sorry. What was it, 3? Which is quite excessive, but if I can fit it in, that's great. I should probably mention what diodes do. They only let power flow in one direction, and they will drop that voltage potential by a tiny bit usually in the process, but that's nothing to worry about here. So that little ring indicator is the blocking side. So current or voltage can't, it's pointless to talk about the direction of electron flow because of power flow, whatever you want to call it, because some people abstract it as the positive being the direction electrons flow from, but I believe in reality electrons flow to the positive side because electrons are negatively charged. So it's all about the voltage potential of the different sides, I believe. But essentially, positive side you want to be here and negative you want to be there. So nothing will flow back to the positive. It'll only flow out towards the negative. So power is going to flow in this direction. So I want to hook it up to here. I'll be able to squeeze it into this spot. And directly solder it there. I should have left some of that lead intact. Oh well. That is not connected. Phew. It looks like that's made a nice big solder bridge in there. It's a bit gnarly, but it'll work. Yeah, it's not going anywhere. That means I'm going to have to remove that last little peg. So this is definitely going to be relying on glue to hold it in. I might trim that down a little bit better. It's my nips. Lovely. So that all fits back together fine. I'll super glue this back together. The world's small. Oh, it's leaking everywhere. Nasty goop. Into the bin you go. This sounds very jelly-like. Oh. I hope this is the last time I need to open this thing up. And I will just sit on this so that that seals, and then I'll talk about the next thing I need to do. After I pack this stuff away. So before I go cutting these cables to, well, this one is the one I'm interested in because it's got the plug. As you can see, I've already shortened this one with itself. You can see the little heat shrink job there. I'm essentially just going to merge these two, but I want to get the length right. What I found handy with this is a small rig cage for the M50. You can squeeze that in through there, pretend there's a battery in there, and that squeezes in. You can sort of lock this in underneath that part of the cage, then that wraps around there. Let me get rid of some of this bulky stuff. Don't need the microphone. I'll keep the light on. If you're interested, this little stand's just a homemade thing, just for holding the light down. No, not light, sorry. It's about a power bank. It's just held on with a really flat screw and a bit of non-slip glued to it, and just a general strap. So this will plug into here. Not sure if I want to use the 1 amp or 2 amp. I think it really matters too much. Well, I'll go with the furthest one. That's roughly how far I need this to reach with this power bank. although push it all the way back. So I'll probably be cutting it around here. I need something to mark that with. I don't want it too tight. Just need room to flex and maneuver the cables. That is not going to work. Doesn't matter. I should be going by the biggest battery I have, not the smallest. Whoops. This mount's a little bit loose. The biggest one I have is this. It's a big bugger. This is 20 milliamps. From when I did testing, the camera takes about 600 milliamps. So 600 milliamps at, oh, was that 5 volts? I can't remember. So once again, from the furthest port. Make sure there's a little bit of slack there. So I'm going to have to cut it around here. Get you out of the way. Probably shouldn't use that. Now I have a spare type C for something. I have to deal with this annoying braid. Feels like it's sort of semi-stuck to this for some reason. This cable also had data. Not sure if this is polyester or not. Might just pause it here while I get this unsheathed. Alright. I'll just tin these a little bit. And make sure this will fit. Lovely. It's always good to preemptively put the heat shrink over It might be a bit too long. Once this is together, I'll keep this little bit because I'll shrink it over that area itself just to help fill in that little gap a bit. Trim some of these little guys. And what I've done with the data cables, one's trimmed flush to the bottom, the other's trimmed a little bit higher. So that just guarantees that they never touch each other, or the power cables. So they're all different distances away. Alright, now I'm ready to solder these together. Just remember, make sure you've already got your heat shrink on the outside. That looks good. Sorry, off screen. So if I can get it to focus, there you go, pretty good. Be careful around that. Lovely. Now what I can probably do, if I can pull some of that sheathing up again. It doesn't want to go far. It's going over a little bit. Oh. There we go, we have a new cable that looks pretty good. So we can go to the bin. Let's just make sure it all works now. I'll try the small battery. Get this in the right way. Get that in. You tilt it, so that's now locked underneath that. Now this will still turn on because the battery inside has charge. Now this power bank doesn't actually indicate whether you're plugged in or not. So that's that cable length, fairly floppy. I guess if I use Velcro, I can Velcro it to that stand. That should work. Now this power bank doesn't show you whether it's powering it. I'll try the other one. The behemoth. Huh. The little LED there's died or become blocked. I'll just wait for that to stop flashing, then I'll try this. Anyway, so I've just been doing a time test. It's been going fine for a past half hour, so that's more than long enough for the internal battery to drain or discharge. So I believe this is working fine. It was working fine with the diode in line, so I don't see why it wouldn't be fine just putting it in the case. But yeah, that's one way to do a fairly modular battery system for this thing.